Alright, you have a slide, Transparency Master 61, which is the pattern of circulation. And what we're going to just review very quickly is that when the blood leaves the heart through the arteries, they're going to exchange something. When it goes to the lungs, there's gas exchange in the lung capillary beds, and when it goes to the body tissues, it's systemic circulation, and gas is exchanged at the capillary beds of all the body tissues. So we've got a number of different blood vessels that are part of that system. Arteries, veins, capillaries. Then smaller arteries are arterioles, and smaller veins are venules, and then the capillaries. And it's at the capillaries that the gas is exchanged. And it's a complete closed circuit. So if you look at the different parts of it in the pattern of circulation, it shows that. And here it shows the capillary bed. It's a closed system. Starting at the capillaries are only one layer of cells, so it makes it really easy for oxygen and nutrients to pass through to the cells, and at the same time the carbon dioxide and metabolic products from the cells to enter the capillaries. There are capillaries in close proximity to almost every cell in the body. Well, I can't get my page to turn. There we go. So I'm going back a slide. Blood is carried through the body from arteries, first of all. Arteries carry blood away from the heart. The largest artery is the aorta, and it receives blood from the left ventricle of the heart and then branches off into all the other arteries that supply blood to the body. Every part of your body needs a blood supply, even the heart itself. So there are arteries that come off of the aorta that go back to the outside of the heart itself, because the heart is a tissue just like any other that needs a blood supply. So that first branch of the aorta is the coronary artery that divides into right and left coronary artery and carries blood to the myocardium of the heart. The myocardium, that middle muscular layer. And then there's additional branches of the aorta that carry blood to the head, the neck, the arms, the chest, the back, the abdomen, and the legs. As the arteries get smaller, they are called arterioles, and they're the smallest branches of the arteries, and they join with the capillaries. Now the arteries are more muscular and more elastic than all the other blood vessels, because they have to be, because they receive the blood as it's pumped from the heart. So they're more muscular and elastic. Those are the arteries. So if you want to know which one of those blood vessels are more muscular and elastic, it's the arteries. Alright, then it connects to the capillaries that I already said are located close to almost every cell. They have thin walls, only one layer of cell, and that's where the blood exchanges with the alveoli in the lungs to collect oxygen and get rid of carbon dioxide and waste. And in the body tissues, it gives oxygen to the body tissues and brings back carbon dioxide and metabolic products. Now, how does it get back to the heart? It goes back through veins, and because the veins are going against gravity, they have valves to keep the blood from flowing backward. So the blood can go through it and then not go backward, otherwise it would pool in the lowest parts of your body. And when the veins get smaller, the smallest of those are called venules, and those join together with the capillaries, and then they get bigger and bigger and bigger until they become veins. And the two largest veins in the body are the superior and inferior vena cava. The superior brings blood from the upper part of the body back to the heart, and the inferior vena cava brings blood from the lower part of the body to the heart, and they both drain into the right atrium. Now we're going to talk about what blood is. Blood is also part of the circulatory or the cardiovascular system, and it's sometimes called a tissue because it contains many different kinds of cells. There are about 4 to 6 quarts of blood in the average adult, and most of you have reached your adult size, so you would have 4 to 6 quarts of blood. And the blood circulates through the body continually, and it needs to. Most important part is the brain and the heart, and you need to keep blood supply to those because the blood is carrying oxygen and nutrients, and we need it in order to live. It does transport many substances: oxygen from the lungs to the body cells, carbon dioxide from the body cells back to the lungs. Nutrients are transported in the bloodstream from the digestive tract to the cells. The cells need those nutrients that we get from the food that you eat, in the digestive system to digest it and then allows it to be absorbed into the blood supply. It carries metabolic waste from the cells to the organs of excretion. It might be excreted through the urine. It might be excreted through the bowel movement. Any of those. It could be excreted through the skin in the form of sweat. The blood also carries heat that's produced by the various body parts, because part of the process of metabolism is to produce heat and energy. And then hormones it carries. Those are produced by the endocrine glands, and they're carried by the blood to the different organs that need them. So the blood supply is extremely important to all the different parts of the body. And these are the things that it transports. Now, the plasma part, that's the fluid portion, and the fluid portion of the blood is about 90% water. So if you don't have enough fluid intake, it's also going to affect the thickness of your blood. Your blood will become thicker and harder to pump if you're dehydrated, because it won't have as much water in it. There's also dissolved or suspended substances in that 90% of water that takes up the other 10%. There are blood proteins that are dissolved in there. Fibrinogen or prothrombin are necessary for blood clotting. There are nutrients, vitamins, carbohydrates, proteins. There are electrolytes. Remember when we had our speaker that was the lab tech, Ms. Belton? She talked about the electrolytes being measured by some of the lab work she does. And the level of potassium or calcium or sodium that's in your blood is important because it affects different parts of your body. If you don't have enough potassium, it affects your heart, and sodium affects your kidneys, and all sorts of other things are affected because of the levels of the electrolytes. Also suspended or dissolved in the plasma are gases, just like in the blood cells themselves. There's oxygen and carbon dioxide suspended in there. Metabolic and waste products, hormones, and enzymes. Those are all suspended in the plasma. There's also solid elements of the blood. There are 3 main kinds of blood cells, or we also call them corpuscles. There are erythrocytes, leukocytes, and thrombocytes. Erythrocytes are red blood cells. They are produced in the red bone marrow, so this is also connected to the skeletal system, because the skeletal system in the long bones has the red bone marrow. And there are 4.5 to 5.5 million red blood cells in every cubic millimeter of blood. A millimeter is very, very small. So in a cubic millimeter, which would be like a measurement of volume, there's 4.5 to 5.5 million of them. Now the red blood cells look like discs, and they have a thinner central area, so it's like a donut without the hole. It's like rounded on the edges and flatter in the middle. If you look at the Transparency Master 63, it shows you what a picture of the erythrocytes look like. It contains hemoglobin, which carries oxygen. The more oxygen it carries, the brighter red it is, and it also carries iron. So this is the part, the hemoglobin, which is in the erythrocytes, that carries the oxygen. There are also leukocytes, or also known as white blood cells, and those are also formed in the bone marrow, but also lymph tissue. So again, we're connected to the lymph system. And there are 5 to 9,000 of those per cubic millimeter, not as many as red blood cells. And their job is to fight infection and produce antibodies. So they're the workhorse of the blood supply. They don't live as long as the red blood cells do. Red blood cells can live up to 120 days before the liver and the spleen break them down. White blood cells only live about 3 to 9 days, so you need to keep reproducing those. And they can pass through the capillary walls and enter the body tissue to help fight function. Now, the process they use is called phagocytosis, and that's when the leukocytes engulf and ingest and destroy pathogens or germs. And you've got a picture on Transparency 63 of a number of different leukocytes. You see there in the picture neutrophils, eosinophils, basophils, monocytes, and lymphocytes. And each of them, those 5 types of leukocytes, have a different way of destroying the pathogens. The neutrophils phagocytize the bacteria by creating an enzyme called lysosome. And the eosinophils remove toxins and defend the body from allergic reactions by producing antihistamines. And the basophils produce histamine, a vasodilator, and heparin. The monocytes phagocytize bacteria and foreign materials, and the lymphocytes provide the immunity by developing the antibodies and protection against cancer cells. So those are the different types. I'm not going to ask you to know all of those. Those are just types of leukocytes. They're all white blood cells. They just have a different job in that. And then there's thrombocytes. We also know those as platelets, and they are formed in the bone marrow as well. And they're very important in clotting, so that you don't bleed to death. Your blood can clot. Normal count of those is 250,000 to 400,000 per cubic millimeter of blood. And they live about 5 to 9 days. So when a blood vessel is cut, the thrombocytes kind of collect at the site and form a sticky plug, and they create a chemical called serotonin that causes your blood vessel to spasm and narrow, so that slows down the flow of blood. And then they release an enzyme called thromboplastin that acts with calcium and other substances in your plasma to form thrombin, and that acts on the fibrinogen in your blood to form fibrin, which makes like a net of fine fibers that traps erythrocytes, the red blood cells, and platelets and plasma to form a clot. And that's very effective in controlling bleeding in smaller blood vessels. If it's a larger blood vessel, that rapid flow of blood can interfere with forming fibrin, and the doctor may have to insert sutures or stitches to close the opening and control the bleeding. Also, that's why we put pressure on a wound that's a large wound that won't stop bleeding, to try to slow it down and allow the thrombocytes to help in the clotting. Alright, so look at also Transparency 64. It also shows the blood cells and the platelets, and there's a lot more detail on there, a lot of fancy words, but if you notice towards the bottom, you've got the erythrocytes, and it showed you the different types above it: the eosinophils, neutrophils, basophils, monocytes, and lymphocytes, all part of the leukocytes, and then the thrombocytes. So if you look at the bottom of the page, it gives you a better idea of the ones above it. I wouldn't worry about knowing all those fancy names. Those are just types of blood cells and platelets. Alright, that's the end of this lesson. The next one's going to be on diseases.